Okay, good evening. Welcome to
FamilyMath number
762.
62.
So today on My Favorite Theorem, they interviewed our friend Patrick Honor, and he talked about a theorem called Varignon's theorem, which says that if you take any 4 points in space, connect the lines up with them, and then connect the midpoints, you get a parallelogram. Following that, somebody posted on Twitter they did it with a tetrahedron. And when you connected the midpoints of they got a square. So can you see some squares in here? That are formed by connecting the midpoints of the tetrahedron? Yeah. All right, show one to the camera if you can.
Like this square.
Okay. So I was able to build this at a Zoom during the day, which was really fun. And then turns out there were 3 squares, and what do?
They make an octahedron and you connect all the vertices up.
Okay, so move it around a little bit so that people can see the octahedron in there. It's pretty fun. So one thing I thought was interesting was this shape made out of Zoom gives a visual proof of the relationship between the volume of an octahedron and the volume of a tetrahedron. And I want you to try to explain, using this shape, what that relationship is once you see it.
Okay. Well, so I'm going to call the volume of one of these small tetrahedrons, like this one on the top.
Okay.
I'm going to call that 1.
You're going to call that 1, okay.
So that means the volume of this big tetrahedron that we have is 8.
Why?
Because the sides are doubled.
Okay.
So the volume is multiplied by 8.
Okay. Do you know why that's true?
Because the area, so the length scales by the number you multiply by, and area scales by the square, and volume scales by the cube.
Okay, good. That's a good explanation.
So since the big tetrahedron's area is 8, and volume is 8, and we've got 4 small tetrahedrons, the octahedron's volume has to be 4.
Nice. So what is the relationship between the volume of a tetrahedron and a volume of an octahedron if they have the same side lengths?
The octahedron's volume is 4 times the tetrahedron's volume.
So I want you to move this around just to show that octahedron in the middle. Does that look like it has half the volume of the big tetrahedron?
No.
Yeah, I don't think so either. Pretty crazy, but it's what the calculation says, right?
Yeah.
But it's funny, it just doesn't look like it has that volume. So this might make a fun 3D printing project, but it was definitely a neat Zoom project, and it was fun to see the relationship. I didn't know previously this relationship between the volume of a octahedron and the volume of a tetrahedron. Pretty neat, right? Pretty neat, right? All right, good job, man.